Black holes, the ultimate cosmic monsters. They swallow stars, warp time, and even break the laws of physics. But what if they never existed? No event horizons, no supermassive black holes shaping galaxies. Even Einstein's equations, they'd need some serious rewriting. Let's start with the basics, how stars die. In our universe, the most massive stars, dozens of times bigger than the Sun, end in a powerful explosion, a supernova. After this explosion, all that remains is a tiny, incredibly dense core. If that core is heavy enough, gravity crushes it into a black hole. But without black holes, what happens instead? Some of these dead stars would become neutron stars, ultra-dense objects just a few miles across. But neutron stars have a mass limit. If no black holes form, does a more massive star just defy physics? The laws of gravity say that beyond a certain limit, collapse is inevitable. If black holes can't form, our entire understanding of how massive stars die must be rewritten. At the heart of every large galaxy, including our Milky Way, lurks a supermassive black hole, millions or even billions of times heavier than the Sun. These cosmic giants help shape galaxies, controlling how stars and planets form. Without them, galaxies might be smaller, messier. Would the Milky Way even exist? Would we exist? Albert Einstein's theory of general relativity predicted black holes long before we ever saw one. His equations showed that if enough mass gets packed into a small enough space, gravity becomes so strong that nothing, not even light, can escape. This equation, describing the event horizon of a black hole, is a fundamental part of Einstein's theory. But if black holes never existed, this equation wouldn't work. Scientists would have to modify Einstein's equations to prevent singularities from forming. Maybe some unknown force stops collapse at the last moment, or maybe gravity itself works differently at extreme scales. Black holes don't just warp space-time, they also warp our understanding of information. According to quantum mechanics, information can never be created or destroyed. Every particle, every atom, every quantum state carries information, and that information should always exist in some form. But here's the problem, if something falls into a black hole, its information should still exist. However, Stephen Hawking showed that black holes slowly evaporate over time due to quantum effects. So, where does all that information go? This is called the black hole information paradox, one of the biggest mysteries in physics. It seems to break the fundamental law that information must be preserved. But if black holes never existed, the paradox simply disappears. No black holes, no event horizon swallowing information, no evaporation, no paradox. Sounds like an easy fix, right? Not so fast. The fact that we even have this paradox tells us there's something deeper going on in the universe, something we don't fully understand. If black holes didn't exist, we might lose one of the biggest clues to quantum gravity, the theory that could finally unite Einstein's relativity with quantum mechanics. So yes, the paradox would disappear, but so would a key piece of the puzzle we need to understand the true nature of reality. Gravitational waves are ripples in space-time caused by massive objects colliding, like black holes and neutron stars. And yes, even without black holes, gravitational waves would still exist. Today, about 80% of all detected gravitational waves come from black hole mergers. If black holes never existed, we'd still detect waves from neutron-star collisions, but much less frequently. This means we might have discovered gravitational waves much later than we did, or needed a completely different approach to find them. No event horizons, no supermassive black holes. Einstein's equations rewritten. The universe would be a very, very different place. But luckily, black holes do exist. And they might just be the key to unlocking the biggest secrets of the cosmos. Wanna explore more mind-blowing space mysteries? Smash that like button and subscribe for more epic space content. See you in the next video.